Hello everyone, myself Sai Prasad, a lecturer in Ahmedabad High School and the Junior College. Welcome to a series of the lectures of Intermediate Second Year Maths A. We started a discussion with our basic chapter, Permutation and Combination. What did we learn? We had a brief introduction about what is a permutation, how do we find the values of NPR and all those. Then we did few problems of arrangement and all those, right? Fine. And if you observe one thing, we have taken all the digits and all the arrangements without repetition, right? Which means for a fixed place we'll have a fixed object. We never had the same object that can be repeated. From today we are going to discuss most of the things which includes the repetition of digits. So how do we arrange? Let us say I have number of elements as n. So how many times it is repeating? Let us say, or else the positions are 4. So therefore the total number of permutations is given as n power r. Okay, there we used to have it as np4. Here we will have it as n power r. For an example, just see here. Find the number of 4-digit numbers that can be formed using 1, 2, 3, 4, 5, 6 elements. Okay, we have 6 elements and there are 4 digits. So how many numbers can be formed is nothing but 6 power 4, since the repetition is allowed. If the repetition is not allowed, we can directly write as 6p4. That's it, fixed, done. Yes or no? Fine, here we will get it as 6 power 4, which is nothing but 1296, isn't it? 36 ka square. Yes or no? Is there something difficult in this? No, right? If repetition is not allowed, the arrangement is NPR. If repetition is allowed, the arrangement is n power r. That's it, fixed. Okay, next. Find the number of 5-letter words that can be formed using the letters of the nature that begin with the letter N. See here, he is telling that 5-letter words, N is fixed, right? 1, 2, 3, 4, 5. Still 4 places are left. 4 places are left. 1, 2, 3, 4, 5, 6 alphabets are left. Right? N is already placed, even though the 6 alphabets are left. Why? Because the repetition is allowed. N can also be repeated again. What's wrong in that? Yes. So we have 6 items and 4 places. The answer is again 6 power 4 here also. Is it right? Yes or no? Here we have 6 elements, 4 positions. Again 6 elements, 4 positions. Answer is 6 power 4. Yes. Did you understand? Fine. If this is not the case, so what would be the answer? 4 positions, only 5 elements we used to have. The answer would be 5p4. 4. Right? Yes or no? Fine. Look at the next question here. Find the number of ways of arranging r things in a line given n things in which at least one thing is repeating. Okay, we have 4 positions. Okay, r positions. Let us say some r positions. Okay, he is telling n things so that only one thing is repeating. Okay, let us say nothing is repeating first. So no repetition. What will be the permutation? NPR. Okay, if I say everything will repeat, if I say repetition is allowed, so what is the formula? If repetition is allowed, the thing is n power r. So what is the thing? At least one will repeat. It doesn't mean that, at least one will repeat bole to it can repeat everything. Yes or no? Either 1 or 2 or 3 or 4. So therefore at least one repetition is given by n power r minus npr. Is it clear? Did you understand? Are these questions not easy? Shall we do a few more problems of this? Let's do. Look at the next question here. He is telling, find the number of numbers less than 2000 that can be formed using the digits 1, 2, 3, 4. Now tell me how many digits do we have? 4 digits. He is telling less than 2000. It can be from 1 to 2000. You can do any number. So let me first write the numbers from 1000 to 2000. How do we get? Just tell me. Given numbers are 1, 2, 3, 4. Done? Yes. From that, let us say the first digit is 1. First digit 1. So it can be like 1. Then we'll have 4 positions. 1, 2, 3. We'll have 3 positions. Since the repetition is allowed, I have 4 more digits. So I can write it as 4 cube. Is it right? Yes or no? Once again see here. Less than 2000. So the first place can be 1. That is something related from 1000 to 2000. Obviously. I have 3 positions. I have 4 numbers. So since the repetition is allowed, the permutation is 4 power 3. Is it clear? Fine. Next. Less than 1000. It can be 3 digit, 2 digit or 1 digit. Yes. So if it is a 3 digit number, so we have 3 positions, right? 4 numbers, so it is nothing but 4 cube again, right? Next, if I want 2 digit numbers, 2 digit numbers, 2 positions, 4 elements, right? Repetition is allowed there again. Next, 1 digit number, 1 digit number, only single number, single element, 4 power 1. Let us all those arrangements now. 4 cube, 4 4 is 16, 16 4 is 64. This is 16 and this is 4. How much is it? 12, 18, 12, 13, 14. 148 is my answer. That's it. Is it easy or not? But the thing is, you have to understand here, I have 4 elements. Nothing should be more than 2000. So we'll come from last. Let us take all the numbers from 1000 to 2000. We'll have 3 positions since repetition is allowed, 4 cube. Right? Next, if it is a 3 digit number, 4 cube. 2 digit number, 4 square. Single digit number, 4 power 1. If I add everything, I'll get it as 148. Is it clear? Fine. Shall we go on to the next problem? Let's do. Look at the next question here. He is telling, find the number of 4-letter words using the letters of the word piston, in which 1 letter is repeated. So what is the formula? Only 1 letter is, first find no repetition, next find full repetition, then subtract it. Right? So we know the formula. What is it? N power r minus npr. What is n? N is 1, 2, 3, 4, 5, 6. R is 4. Obviously, the arrangement is nothing but 6 power 4 minus 6p4, which is 1296 minus 6 factorial by 2 factorial. That is nothing but 6543 divided by 2 will get cancelled. That is 1296 minus 6 5s are 30, 4 3s are 12. 30 into 12, again 12 3s is 48. Right? 6 5s are 30, 4 3s are 12. 12 into 30, 480. Just subtract it. 1296 minus 480. How much is it? 816. Clear? Fine. Look at the next question here. Find the number of 4-digit numbers which can be formed using 1, 2, 3, 4, 5 digits including 0 that are divisible by 2, 4 when repetition is allowed. Clear? Now tell me, how many digit do they want? 4 digit. Right? So in that 4 digit, if I want it to be divisible by 2, 1, 2, 3, 4. If I want it to be divisible by 2, the last digit should be either 0 or 2 or 8. So I can arrange these 3 elements in this position in 3 ways. First thing done. Next, since it is 4 digit now, this position is fixed, either 0 or 2 or 8. Next, since it is a 4 digit number, we cannot have 0 here. So the remaining numbers we have to arrange. So since 0 is not allowed, I can put 4 different numbers here. 4 power 1. Still how many places are left? 2 places are left. There are 5 different digits. So I can write it as 5 square. Is it right? So what will be my answer now? Therefore, the total number of arrangements is 3 into 4 into 25. 25 4 is 100. 100 3 is 300. That's it. Is it clear? Fine. Next, second question. It should be divisible by 4. Since it is a 4 digit number, these 2 positions has to be filled. What are the different positions we can fill in 4 table by using these numbers? Again start now. 0 0. Right. Next 2 0, 2 8, and the next 5 0. 5 0 it doesn't go, and the next 5 2 it goes. 5 8. Next 7 0. 7 0 will it go in 4 table? 35? No, it doesn't go. So obviously 7 2, 7 8, 8 0, 8 8. Total 1 2 3 4 5 6 7 8 9 numbers we got it. Is it right? Right? This is correct. 0 0, 2 0. We can write 0 8 also. It is also possible. 2 8, 5 2. So 5 8 is not possible. Sorry. Next 5 2, 5 7, 52, 56. Okay. 72, 76. Okay, so this is also not possible. Now count 1 2 3 4 5 6 7 8. Okay, so we can arrange these 2 places in 8 ways, right? Obviously, since the first digit should not be 0, we can arrange 4 digits in this first place. So we can arrange in 4 ways for the first place, and still only 1 place is left. This 1 place 5 digits, so it will be like 5 power 1. Now just total arrangements are 8 into 4 into 5. 8 4s are 32. 32 5s is 160, or else 4 5s are 20. 20 into 8 is also 160. Clear? Did you understand? Fine. These are the basic questions of permutations when repetition is allowed. What all we learned till now? We learned permutations when repetition is not allowed. We also learned permutation when repetition is allowed. What if they are arranged in a circular manner? What if one is repeating? What if it is going clockwise? If we are going anti-clockwise? Fine. That is a special concept which we are going to learn now. That is circular permutation. Shall we do? Let's do now. What is the circular permutation? Till now we discussed how the number of arrangements can be made. First just tell me, let us say if I have some name like and, I have 3 letters, 3 positions. So I can write the number of permutations it can form is 3 factorial. Since we have only 3 elements, 3 positions are placed in a linear manner. What if I have something like this word? I have 5 elements, 5 positions, but you have to understand is there are 2 elements which are similar. So I can say 5 factorial, out of which one element is repeating, right? Yes or no? How many times it is repeating? 2 times. So we can write as 2 factorial. Clear? Did you understand? Let us say some word like just tell some word. Mathematics. Mathematics. Total how many letters? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 factorial by how many are repeating? M1, M2, A1, A2, T, T1, T2. Next H not repeating, E not repeating, I, C, S no not repeating. So did you understand? So the linear permutation is always given by n factorial by p factorial. This p is nothing but the number of repetitions. If there are more repetitions, we can just write everything in the denominator itself. Clear? Fine. What about the circular permutation? Let us say there are a few number of elements to be arranged in a circular manner. If I say I am starting from here, I will go like this, I will arrange everything and come here. Okay. So it can be nothing but n minus 1 factorial, which means we are going to remain this number unarranged because we are considering it as a reference. We'll start from here, so we need to arrange remaining things. That's why it is simply n minus 1 factorial. Fine. That I am coming from this side. What if the direction is not at all considered? We can come either from this side or from the anti-clockwise. So we can write the permutation as n minus 1 factorial by 2. Clear? Did you understand? Fine. Now see here. Find the number of ways of preparing a chain with 6 different colored beads. Different colored beads. Did they specify that this should be the order, this should not be the order? No, right? So since it is a kind of chain in which we have to arrange 6 beads. Yes, 6 beads in a circular manner without any direction consideration. So directly the answer will be 6 minus 1 factorial by 2, which is 5 factorial by 2, that is 120 by 2, that is 60. Done. Yes. Next. Find the number of ways of arranging 7 gents and 4 ladies around a circular table if no ladies wish to sit together. Right? This is some kind of circular table. They are telling that no ladies sit together. So first we have to arrange 7 gents. How? 1, 2, 3, 4, 5, 6 and 7. Okay. The ways of arranging gents in a circle. Okay. However, we'll start from this. It will be like 6 factorial. Isn't it? Next. Now we have to arrange 4 ladies within this place. How many places do we have? 1, 2, 3, 4, 5, 6, 7. In the 7 places, we have 4 ladies. Now arranging ladies is in 7 positions. We can write 4 people. So obviously, therefore, the required arrangement is 6 factorial into 7p4. Is it clear? It is so simple. But the first thing is, since it is already arranged in a circular position, we can consider them as linear and we can write it as in 7p4. Is it right? Yes or no? Irrespective of other things, we have positions, we have arranged. Yes, there is no consideration of about it is circular or not. Circular only when we arrange initially. Is it clear? Did you understand? There are few more problems of circular permutations which we will do in our further sessions. What did we learn today? We just learned the repeating, the permutation and the repetition is allowed. We did most of the problems and then we learned what is circular permutation and this kind of problems. Clear? Fine. This is for today. Let us meet in the next session with the more problems of permutation and combination. Thank you.